So there is a document that's linked in the chat. It's also linked in the channel on Discord. I don't know if everybody's in that channel yet, but we can get people connected to that. If not, let's see. Go ahead and. So I think, yeah, we're live on YouTube. This is, welcome to Hacknight number 18. Is it? No, it's 19. Why does it say 18 at the end? Let me edit this. So we're on number 19. Right? I don't know why I have this old description. Save it. Maybe it just copied over from the last time. Anyway, so the Aframe WebXR Online Hacknight is, let me go ahead and see, where is the document that I just created? It has been meeting for 19 times. We've worked on a variety of code projects. The one that is the most well worked on would be the Gravity Gloves component. Let me see if I can find that component real quick. So Gravity Gloves, A-frame. Okay, so this component right here, if you're in VR on Oculus Quest and you use your left or right hand, you click on something, it comes to you, and it's kind of similar to the Gravity Gloves in Half-Life Alyx. That was our inspiration. So that's kind of like probably the most complete thing we've done. As a group, we've been discussing how to create post-it notes, and we've discussed as a group how to get the thumb controls working, and one of our members, Mignon, helped a lot with both of those projects. But there's a lot of things we'd like to do, and this week we have Eric has decided to come back and resume a lesson that he started last week of showing us how to do cool things with WebGL 2 and instancing. And last week we learned specifically how to address unique instances in order to modify their vectors individually. Besides colors, you can also multiply the vectors and change and deform the shape. So that was cool. And then we have a new lesson from Eric this week. So I'll go ahead and hand the floor over to Eric. If you would like to cast your computer and take over, and I'll go ahead and let me reduce the noise of my background here. That's awesome, Mignon, by the way. It's really awesome.
orientation, obviously. It's just, you know, which way it's pointing in the swarm. That one's random. And then it makes a data texture, which is a Three.js thing. It's not much different than a texture, but I think it has something different. But the name sounded appropriate, so I used it. And here's the raw shader material. So so I just pass in the shaders that I already showed. And there's just a few uniforms here. One is the data texture, that's the important one, and then these two matrices. So it's kind of like one of them is for the object that's selected, and one of them is for the previous object that was selected that's now moving back. Shaders that I already showed. Create the mesh and add it. And here's my. So I actually did kind of have to implement the Raycaster. I mean, it's not obviously not the whole thing, but instance mesh has a Raycaster, which is nice because they implemented it so that if it hits something in the mesh, it returns to you. And so the information that you get back when you do a Raycaster includes things like the point of intersection and stuff like that. And in this case, it also returns an instance ID. But since I couldn't use the instance mesh, I had to kind of implement that code myself. So that's what's going on here. It's, I'm basically iterating through all the instances and checking for, and then calling Raycaster on that, which is right here. So you know, for each instance, then I call the Raycaster again and check it. So this code right here is just that's accounting for the fact that the one that so the selected tetrahedron is going to be in a different place. So it's just the like that dealing with that special case to see if you know, when the Raycaster is checking if it intersected, it has to look in the right place for that one. So that's the Raycaster. Render, nothing special. Okay, so then here's the render code. So it just checks to see, you know, if you've clicked. There's a mouse handler somewhere that's checking for clicks. And so if you click, then it does the Raycaster, and if it comes out positive, then you set instance click to true, and now you have your selected instance ID and vertex ID. Okay, then so in the renderer, so the next, you know, if you click, then it does. So this is where it is changing that, you know, the data that's. So now it's in that texture. Oh, also in the Raycaster, it's also figuring out which vertex is closest, by the way. So that's where the selected vertex ID comes from. So it just finds the place in that table where that, you know, for that instance and that vertex and that and the the RGB components and makes it red, and then it sets the A component to 0. So that's the part, and it does it for every vertex of that instance. So A equals 0, that's the signal that says this is the selected one, so make it stop moving. And then shift. So it's just checking to see, this is just special case codes. If you clicked on the same object, then it doesn't, then it will just skip this code here. But if you are shifting, so either you clicked on a different object or you hadn't clicked on anything yet, then you do the shift. So that's where like the one that was selected becomes the previously selected one. The one that you just got becomes the current one, and so this is where you save. This is where you save that matrix. So whatever the model view matrix for the whole swarm is at that point, it's kind of taking a snapshot, and that's what it's going to use as long as it's the selected one.
This presentation was really amazing, but I have to say that I think we may have had an audio issue that I fixed about 3 minutes ago. Mignon, would you do you feel comfortable maybe going over just a basic overview of your presentation again, maybe another 5 minutes, just go over the whole code again?
What? In another 5 minutes?
Well, no, you can go longer. You can go as long as you want. I'm just saying, like,
no, but I don't understand what you're saying. You want me to?
We lost
back
the
up
beginning.
5 minutes?
We lost the beginning of your audio. We have basically the last 3 minutes of your audio, and so.
Oh, you only have the last 3 minutes.
Yeah, if you want to get it on record, now the audio is working.
I don't care about getting it on record.
Well, I mean, I think it would be really great for everybody, but
I don't want to bore everyone to death.
No, this is great.
This is amazing, amazing.
It's a really amazing code, and I'd love to preserve this forever. If you don't mind, we'd love to hear it again.
Well, if nobody objects, I guess.
Part of your legacy.
Yeah.
Oh my God.
If you want, you can even show the demo again. I've got the demo running on the recording, but you can, if you want, you could do that part again too.
Think of the community and your descendants.
Yeah.
All right. You know, I really hate public speaking. All right. Where is? Okay, so here's. I need to change what I'm sharing, I guess. This. So do I have to say the whole thing about the?
It was actually really great.
Post-it notes and all that.
I would. It was really good, great.
All right. No. Sharing screen breakdown. All right, so this is the demo I made where I was demonstrating being able to save information per instance and per vertex using instanced buffers. So the idea that I have in mind here is the post-it notes that we've been talking about, where you have a bunch of post-it notes that are all instances, and you want to be able to select one of them and edit it and have it save those edits but still just be an instance. So so this is a kind of a symbolic representation of that. So these tetrahedra, these are all instances of the same geometry, and you can, so if you select one of them, then it stops. So it's like you're grabbing it, and then you can edit it. So the only editing you can do at this point is by clicking on the vertices, you can turn them red. Just on the side that's facing you, unfortunately. So I can't do the ones on the back, but so now if I click another one, the one that was selected goes back to its location in the swarm, and now I can edit this one. Let me pick one that has more than one face visible, so at least you can see that, that you can edit more than one face. And so when they go back to the swarm, they're keeping their edits. So it's like you've edited those post-its, and then they stay that way until somebody else changes them. So this is just a very simple kind of proof of concept of the doing post-its as instances idea. So now I'll show the code. Okay. All right. So this is the code. It's 3JS code. So the reason I wanted to do that instead of just pure WebGL is because I didn't want to do things like implement my own Raycaster and stuff. I mean, 3.js has obviously a lot of great stuff in it, so I want to be able to take advantage of it, but I also wanted to be able to do my own shaders and stuff. So this was a experiment where I kind of started learning how to do that. So here's the Vertex Shader, and so this is the most interesting part of the data texture. That's the that's basically an array of data that's keeping track of like for every instance and every vertex in each instance. It has 4 bytes of information basically. So 3 of those are used for color, and then the other byte I'm using that for something else. So the 4th byte would is the alpha component of color, but I'm not using it for alpha. I'm just using it to have some additional bits of information. So the first 3 bytes, the RGB, that just gets passed down to the fragment shader here, which basically that's all the fragment shader does, is it just takes the
I was going to say, if you want, you could temporarily hide the directory on the left side, and then we have a bigger view of the code, if you want to.
Okay, thanks.
Sure.
So the fragment shader is just taking, it just has this one input, which is the data, and it's just using the RGB as the color, and then setting the alpha to 1. So here's where I use that extra piece of information that I have in the data. So the default is that the alpha component is set to 255, so that would be the last case, and that's the normal that's the normal default Vertex Shader code. But if it's equal to 0, then it's going to use this model view matrix instead, which is this is the model view matrix at the point where you selected the object. So it freezes that matrix so that effectively that freezes the object, because it doesn't. So when this model view matrix changes, this one is still the same. So so any object, any instance where the A component is set to 0 is going to look like it's going to not be moving along with the way that all the other instances are. And then if it's in between, that's how I implement the pieces that are moving back to their original location. And this is computed in the render code, which I'll get to below. So here is this is where I set up the vertices for the tetrahedra. This is initializing the offsets and orientations for each of the instances. The orientations are completely random, and the offsets are. This just makes them go on a spiral. That spiral that you see in the demo. That's so that it's easier to see. It's easier to see them going back to their original location that way. And these matrices here, this is, I need that for the Raycaster. So I'm just, I mean, I could recompute them later, but it's just using the offset and the rotation, and then the scale, which is just the identity matrix, because I'm not doing any scaling, and so it's just keeping basically a local matrix for each instance. And then my geometry is an instance buffer geometry, and I'm doing so. 3JS has an instanced mesh that takes care of all this for you, but I couldn't use it because it's a little too high level and it doesn't let you manipulate things as much. So I'm just using a regular mesh, but an instance buffer geometry. So here I'm setting up the attributes. So this is just the regular attribute of the positions, like for each separate component of each vertex, and then these are the instance attributes. So each instance has an offset and orientation. And this is where I set up the initialize the data matrix that has the 4 bytes for every vertex of every instance. And so it's just defaulting to the, you know, the green, yellow, blue colors with setting the alpha component to 255. And then making a data texture out of that array. By the way, this seemed to be the limiting factor in how many instances I could have. Not that I tested it that much, but if I made more than, so I could do 10,000 instances, but if I tried to do 20,000, it complained because it said the texture was too big. So there may be ways to deal with that, but at 10,000 instances, it was still, you know, it didn't seem to have any, it wasn't slowing down at all, so it was good. Not that it's very challenging geometry. So here's the material. So it's raw shader material. So you can just, so I'm just passing in the shaders that I already showed you and the data texture that we talked about, and then just these two matrices that are for, you know, it's for the selected object to, and then the one for the previously selected one that's moving back home. So here I create just a plain old mesh using the instance buffer geometry and the raw shader material, and then add it to the scene. So that's the only thing in the scene. Then here I had to implement a Raycaster because I needed to be able to see which particular instance was being hit. So the instance mesh class in 3JS has a Raycaster in it that does that for you. That tells you, you know, if you've hit anything in it, and if you have, it tells you which instance it is. So I basically copied that code and then added the stuff that I needed to account for the one instance that isn't moving, so you can see if you've hit that one, because you have to apply a different matrix for that one, and I also added code to, so this code here is to find this code here is to find which vertex you've hit, not just which instance, but which vertex, or which vertex you're closest to anyway. And so then, so in the render code, then I am checking to see if anybody's clicked. So there's some event listener somewhere that's listening for clicks, and then if you click, then then the Raycaster checks to see if you've intersected anything, and if you have, then that sets the selected index instance ID and the selected vertex ID. So then if you did click on some instance, then it starts handling that. So whichever instance and vertex it was, it finds the place in the data matrix, and it sets the color components for that vertex to red. And then for the alpha component, so it just does that for the one vertex, the selected vertex, but then for every vertex of that chosen instance, it sets the alpha component to 0. So that's the thing that it uses to signal that it's time to stop moving. And of course you want the whole instance to stop moving, not just the one vertex. So that's why it does all the vertices. Then it checks to see if you just clicked on the same object that you did before, in which case it skips over this code. But if you did, so that's called a shift. So now it's shifting. So the selected instance becomes the previous selected instance, and the current one becomes the selected instance, or rather the current model view matrix of the swarm, I like to call it the swarm, becomes the model view matrix for the selected instance. And then so if you selected something, then the one that was selected is going to start moving. If there was another one that was already moving, then it has to stop that. So so then it sets it to 255 because it can only handle one of them moving back at a time. So in that case, if it was only halfway back, it would just snap back into position, and then the one that was selected, it will start moving back. And then what this is doing here is I don't know if I mentioned before, or at least in my second run through, that the A component, the alpha component, is it's basically counting up from 1 to 255 as it's moving, and so that since it's doing it once per frame, that's about 4 seconds. So this is where that incrementation happens. So, if it isn't already at 255, then so it increments the A component that's here, and then it does the interpolation. So it's basically interpolating between its current position and the model view matrix of the swarm. So so it's going back home. So that's so this P1, Q1, S1, and P0, Q0, S0, those are just values that I declared earlier so that I can just reuse them. So this is kind of the target of I'm interpolating from A to B. So this is A. No, this is B. So this is what I'm aiming for, which is the model view matrix of the swarm, and then this is A, which is the current location. So I'm just doing some, interpolation here, and then saying the texture needs to be updated, and so this is the how the what makes the swarm rotate, and it updates the uniforms and renders, and that's it. So is anybody still awake?
Yep.
That's awesome. That is awesome.
Yes, that was really great, and we got it all on the YouTube video.
Great.
Yeah. So I mean, I don't know if you covered this. I guess I can review. I will review the YouTube video again. But did you sort of cover like how, when you select an object, it stops in space where you selected it. But then when you click on a different object, it moves back to its rotation pattern. Did you must have covered it because you covered everything. How does it know how to return to its previous pattern?
Well, that's what's happening here. That linear interpolation I was talking about.
Mm-hmm.
The so if the matrix that it uses is the this here, the object.modelView matrix, then that means it's back home, okay? And then
Okay.
if it's using the, not this one, but the model view matrix for the current selected vertex, I can't remember what it's exactly called, but this one here, okay? That's the one that where it stopped, okay? Then when it shifts, the previously selected instance becomes a copy of that, okay? And then here, what I'm doing, so originally, it's going to be in the same place, the same stopped place that it was. But then gradually, as I increment A from 0 up to 255, or actually from 1 up to 254, what it's doing is it's linearly interpolating between this one, which is the the place where it stopped, and this one, which is the place where it belongs in the swarm. So this linear interpolation here. So the way to do that is you decompose the matrix into its three parts: the position, rotation, and scale, and then you linearly interpolate the three of them separately. And as so the bigger A is well, this is a little tricky because I'm not exactly just interpolating between the 2 points, because I keep changing the first point, right? So I am linearly interpolating, but then the new point that I get is so right here, what it's doing is it's kind of replacing this matrix here with the value that I am linearly interpolating. So it's getting closer and closer, and then, but each time the fraction of the way that it interpolates gets smaller. So let's look at the first one. So when A is equal to 1, this is going to be 1 over 254. Okay, so that means it's saying go that fraction, like 1 over 254. So that's what, like 4,000ths of the way from point A to point B. And then as A increases, that fraction is going to get bigger and bigger. But also you're getting the point that your starting point is getting closer and closer to the end. So effectively, you're going at a constant rate. But it's just I don't know. It's just easier to do it that way, because I don't have to keep the beginning point and the interpolated point. I just keep moving the starting point.
I mean, that's just really fancy code, fancy math. I like it a lot. I wouldn't have thought to do that.
Yeah, well,
it's nice.
I had fun figuring all this stuff out.
That is exquisite.
Thanks. All right, so can I stop sharing now, or?
Oh, could you leave it up there for a second? because I want to bask in the glory of this just for.
Okay, well, I did put a link to it in
Yeah,
the.
I understand. Okay, sure. Go ahead and.
So Eric, you may want to reintroduce your work. I'm not sure what was on the audio originally or not.
Okay, so
But the audio is for sure working now.
so you can hear my audio, okay?
On YouTube, yeah, I checked your YouTube and it's coming through.
All right. So now, oh, Mignon, that's awesome. So that last section that you had just asked about right there, Micah, in regards to the interpolation between the, going back to the swarm, right? I love that swarm too as well. So I clicked the wrong one. So essentially, that's a really good place for people in that technique that she used right there to look at the whole idea of the composing matrices, right? The compose of column vectors, and that's because last week I think I shared, didn't I? I shared like everybody, or not everybody, that's presumptuous, but 3 blue, 1 brown, as well as the open courseware linear algebra links that I put in last week would be very relevant right there when you're talking about the composed matrices of column vectors, and then the decomposition that she did right there, and then the scalar interpolation of each of those vectors that's a perfect place to take a time out and shift, to use another one of her terms right there, and kind of shift gears a little bit and just focus for a little bit on the math part of it, because I don't think and this is awesome. It's so awesome to bask in the beauty of everybody's different ways of going about different getting basic functionality done. That was just exquisite. But over here, here's my remix that I did, and here's that in the examples, and this is where it left off, is in this file called WebGL instance drawing. Now, so I'm not leaving a big discontinuity for people because people are going to probably just jump ahead once the word gets out. They're going to jump ahead to that part in the video, and you should do that. You should just have it jump right ahead to Mignon's part. But if you didn't already go to the bit.ly, and then it will take you to a project that you can remix. You could click the top right to make your own copy, or go over here and click remix. Then you're set up, and then you can show the actual, I guess, the root of the public folder. Just go over here and click, and then it will automatically render the index.html. And then you have this little page here to organize some of this stuff. Now, what I'm gonna do here is I'll make another post here based on Mignon's example as well, because I think this is awesome. Last time we started kind of like at a medium level, because we were using another library called TWGL as well. And I think it's healthy to go through these different levels of the software stack and deal with the same basic thing. And that's going to reinforce everybody's chops when it comes to expressing themselves in the context of shaders and vertex array objects and so forth. So particularly down here, you would have clicked source. It would have brought you back to my original, this original really ugly looking directory structure has all these, because and again, I want to give attribution against this, going back here to, let me actually just, not in here for a second. Let me just close this up. I just want to give attribution again to Greg Tavares of WebGL2, which should be WebGL2 Fame, because he put together so many awesome things. But it would take you over here to this web instance drawing projection view HTML. It's in the examples, and that's basically where you would go within your individual remix. So if you haven't remixed this yet, go ahead and click the remix button in the top right, or go over here to the drop down and click remix project. That way that you can go in and you can edit all the code yourself, all right? Because what we're going to be doing here now is excellent in the fact that it's going to be a nice step up from like what we did last time, and it's going towards like what Mignon did, and it'll be a nice kind of get you on that trajectory towards going to that in that direction, but of course winding up in your own unique place. So I'm going to go ahead back to my remix version of this, and let me go ahead and, I don't know why this window's sticking around. All right, so down in this HTML, it just has inline JavaScript, and essentially I'm doing something similar to what I did last time with leaving some things commented that you can uncomment. This time through, I didn't get explicit about it because I thought it could just be like a thing. So for example, I just set up this, I'll give you a little bit of my naming rationale. Over here, I called this on line 59 FIID. So it's this float based upon the index, because the instance ID that we get over here, all I'm doing is I'm casting it to a float, because it was, in this case, as Mignon mentioned last time, when you're in the ES300, as you can see over here, this particular version of the spec for the OpenGL, as well as the OpenGL 3, essentially, which is being implemented here. So 3.1 would be like 310 for implementing those things whenever they do that and so forth. So this is a compiler directive, and it tells the compiler to basically interpret, to go and tokenize all of these things according to this particular version of the spec, which is basically the 3.0 version of the spec. Down here, I'm taking that ID and making it a float, and then down over here, all I'm doing here is I'm taking the power function base2, and I'm just using that as a way to make it a little bit more, have a more amplified effect. And then down here, I just basically use that value. And this is to stand for actually the index influence. So I'm letting this stand for index influence. I should have probably used better naming. But II is supposed to stand for the influence of the instance ID so that the influence of the instance ID on the offset. That's what the IIO is stand for, and this is just making a specific offset that's based on the instance ID's influence. And then down here, the same thing, except it's based on the vertex ID. So this is taking the vertex ID, casting it as a float in this case, and the vertex influence, just amplifying it by using the power function, and then the vertex influence of the offset, or vertex influence on the offset, and that's what this is right here. So initially, these aren't even being used initially. Those are things that can get changed down the road, because if you look at what I've done down here, is on line 71, you can uncomment this to get the influence of either, so 70 and 71, you can, if you uncommented 70, it would add in the influence of the index. And then if you uncommented 71, as you can see here, it has the extra term, which is the influence of the vertex on the offset. So this A position is just the base offset for that particular instance. And then this is going to go ahead and offset it further, and based on the instance ID or based on the vertex ID. Initially, I have both of those commented out because you can see the active case down here is, or this line 74, we're computing the GL position. And that is right there. If we wanted to say the world position, we're using that. Now we have the model position, the matrix basically here, which is like the model, and then the view, and then the projection. So over here, the projection is, so the matrix is like the model matrix. The view is like the position and rotation of the camera, if you will. And the projection is the type of lens hardware type of camera. In this case, it's just using a orthographic view, which is like a rectangular cross section of the clip space, which is the fundamental space that's in Shaderland. And then down here, it basically is passing on this vertex color to the fragment shader. So in this, again, it's important to understand that in terms of migrating from WebGL to WebGL2, you no longer specify attributes. You're specifying in values. You're coming into the graphics pipeline. So you want to think about it as like a pipeline at this point, this process that you're doing one thing then the other and so forth. So you're coming into the graphics pipeline from the data that's in your, in this case, like a vertex array buffer, but it's basically just the GPU data, some flat, laid out data, and it's coming in from the data. And in previous version of WebGL, WebGL1, this would have been identified as attributes, but no longer. In fact, that will give you an error. And then uniforms are still uniforms. In this sense, as you can see right there, but you don't use varyings for kind of shared pointers, if you will, or pointers to the same thing like it would in WebGL1. You use out because when you're going from the fragment or from the vertex to the fragment, you're going out of the you're going out of the vertex shader, and then that's going to be coming into the fragment shader. So when you go down into the fragment shader, you can see that in is that B color. Up here, it's out because that B color is going out of this part of the pipeline, and it's going into this part. So the first part of the pipeline is the actual layout of the data in the GPU. And then it goes into the, well, this is kind of, there's a couple of things that are getting jumped through. This is like the simplified version of the graphics pipeline. But we can think of it this way. It's coming in from the data in the GPU. Then it's going into the vertex shader, and then out of the vertex shader into the fragment shader. And then the fragment shader is your last stop. And it's important to do as little as possible in the fragment shader. I don't think I made that point last time. The fragment shader, if you think about it in the slightly inaccurate, but in terms of order of magnitude, it is pretty accurate. If you think of the fragment shader as being kind of like a for loop, like this main right here, you can think of that as being a for loop where it's looping over every single pixel. It's not exactly that because you have to go between a couple different spaces. because the fragment's going to exist in clip space. So it has to go through a couple different spaces, but the order of magnitude greater that this iteration or this this iteration is, this loop is, if you will, compared to the fragment is, oftentimes, like 10,000 times. It's not always the same, but you can say 10,000 is a nice, order of magnitude, or, just if you just wanted to say, base 10, just, 10 to the fourth or whatever. So if you can ever do something and compute it in the fragment shader, or in the, if you could ever do it compute it in the Vertex shader, you should do that. Because you're going to be doing it, you're going to be looping through the Vertex shader only once per vertex. Especially in these examples, we hardly have any vertices, right? So it's like, I mean, and here you have like, you can have like millions of pixels, right? So you can have millions of pixels, but only have like a handful of vertices if you have a simple example like this. And it would just be crazy to do some type of, calculation down here in the fragment shader that you could have done in the Vertex shader. So that's just a common practice that you should keep in mind. You should do as little as possible in the fragment shader, as much as possible in terms of computing in the Vertex shader. So that said, if that was kind of laying the ground right here just for these activities pretty much at this point. If we go over to the kind of like that project. So when you did the remix, if you go to show in a new window, it'll open up this page. And if you go down to this link right here, the top bullet, the front link, if you just click it, this is the really, really simple demo right here. And this is, again, this is a modified version from the WebGL2 lessons by Greg Tavares. And so right here, and then you can click to go back to the source or go back to that page. Right here is where we're going to do our kind of independent learning. And I want to encourage, oh my gosh, we were blessed so much with Mignon's presentation. Everybody here, I expect in the coming weeks, is going to step up and share this stuff. And I appreciate so much what Mike has been doing for 5 years. I didn't realize that until watching all your videos, that you've been at this since 2015, maybe even before that.
Oh, thanks.
But that's amazing, because the documentation, there's nothing, nothing more like a solid, salient fact that everybody's going to agree is a fact, right? Because a fact is something that we all agree is true. And I think everybody can agree it's true when the community is stepping up as individuals, when you're democratizing the platform, the soapbox, and you're documenting what everybody has to kick in. That's where it's going to accelerate so much in the community, and everybody's going to benefit, especially when we're in this burgeoning state of growth in the industry, and we could really get things going that much faster. So over here, to that effect, in my attempt to get more documentation on top of this whole thing, is to have you go to the Super Medium Discord. You can go to anywhere. As a matter of fact, I even link back to in the other, like on this document right here, I even linked to my Discord. Shameless plug right there. So I even linked to my Discord, which you're welcome to post in as well. Some of my students will be in there, so you have to be very mindful of that, but in terms of protocols. But let me just go ahead and go back to that. Now, what I've done right here is I'm encouraging everybody to post into Discord and step up and just make some responses there to these prompts, these instructions. We'll look over these in a moment. And this is where everybody's going to be active. And then whatever the relevant code is, it's whatever you think the relevant code is as well. I'm not going to tell you. This is part of, diving. It's part of your journey, right? So, but whatever that relevant code is that you think is relevant, then you go ahead and put it in the triple backtick kind of markdown syntax so that it shows up nicely in the Discord or whatever. And that same syntax will work on Slacks too. But if it's not a corporate Slack, you're not going to get all this. You'll lose data over time, right? So down here in the instructions, the first one is describe a fundamental difference in the data type / structure between the color location and the view location. So obviously, or maybe not so obviously, this is part of, these are things that you would find in the code over here. So if you kind of get over here into this document, now this is kind of obvious, but you can, on glitch, right, you can just obviously go and just search. So this is obvious. Most people would just do the Command F or Control F or whatever keyboard you're on, and operating system or what have you in browser. But hopefully you're using Google Chrome actually for this, because I'm going to mention a little bit of DevTools specific, Chrome DevTools specific stuff. But if you just like search for color lock, color location, you can see where it gets declared and initialized over here. And if you review that, and so here's the color location variable. What was the question? Oh, I forgot. What's the difference in data type or structure between the color location and the view location? So down here, color location, and then down further, we have the view location. So you should be able to see there's slightly different things getting put into each of those variables. So if somebody can step up and say what those answers are. So color location is getting what kind of thing into it? It's going to get an attribute, location attribute. So over here, right? It's so it's getting specifically in this case, it's getting a location attribute. Now, what does that mean? You might even wonder at this point. Well, it's kind of like you're getting the we're going to say things slightly inaccurate. Basically, it's going to point to the address. It's going to map. It's going to map to the address. Put it that way. That the this data is going to be in the GPU memory. So it's going to be important down the road to pass that information in whenever you're binding things. And binding is just going to be moving a pointer basically on the GPU. So you're going to tell like a pointer to go to a certain offset. It's going to go through a certain mapping based on this location. So this is an attribute. But what is the view location? It's not an attribute, it's a what?
Uniform.
Yes.
Oh, I guess I'm supposed to type that, huh?
Yeah. If you put that in your post. Yeah, so it's a uniform. And the uniforms are basically, right, they're this kind of throughway, right, that you're sharing between the CPU and the GPU. Now you can manipulate and reset data that deals with attributes as well. You can bind different data and unbind them and change it. But no, that's going to be a lot more costly in terms of the that kind of interaction. So whenever you're changing things frequently, if you can get away with that being done via uniforms, that's going to be better. But when you actually look at the values of these, you see how I'm console logging those, you'll see this just sets you up kind of like with an object that can be used to talk. Kind of like, remember when we were kids or whatever, you talk through like a tube, talking through a tube to, basically when we talk through, a tube to somebody, we used to go out to the highway or to a road and talk through like those little culverts, those little tubes, drainage pipes and stuff. You ever talk across the road to people? weird like that, probably shouldn't be revealing so much. I'm sorry about that. That's, yeah. Don't play near the cars. That's exactly why I went there, because they said don't do it. Don't play near the highway. But anyway, so it's like that. So the uniform, when you get the uniforms, it's like you're getting the uniform location. You're basically getting this object that allows you to talk through. It's kind of talk through to the GPU. So you'll see when this is console logged that it's not going to be like you'll see over here that these are just like basically integer values that are going to be mapped to addresses on the to actual memory addresses on the GPU side. So these attribute locations are just going to give you like these integer values that are, you can think of them as being part of like that are going to basically map to an actual memory address in the GPU. So let's go ahead, and before we go any further, I think I gave you enough time to answer that. I was trying to kill some time there with the first question. Instruction. Describe a fundamental difference between the data type and the structure. So the actual, I think I mentioned that. So in terms of, you get the attribute location, and then the other one is the uniform location. And let's go ahead and open up with Option Command J, or it depends on which computer you're on. Go ahead and open up your JavaScript console. And oh yeah, I started the layout. Let me go ahead and. So in the JavaScript console, if we go ahead and fire this up again, so it's, oops, where did I? Oh, that's right, I didn't. Let me, why did I want it? I thought I did. Yeah, so let me go ahead. I knew that's one thing I didn't jump in right before that. So if we can go fix that one reference, null reference. Isn't it so great how, you know, JavaScript can take a null reference and doesn't just like totally, you know, have a exception and just throw the world at you. So right over here, I'm just going to go ahead and just avoid that right now. This could be something that you take care of. I'll just, because I think, did I start to put it up there, but I just put it I put it in the wrong scope, right? Is that what I did? Did I go over here or I didn't save it, period. Let me see. I thought I guess I didn't. So I left that for you to instantiate. So it's just so this doesn't throw an error for right now, I'm just gonna put const, and you can use whatever, you can declare it as a const or whatever in the future. It doesn't have to be, well, actually, we're gonna be changing all, let's go ahead. Let's just do let, just to be more explicit, but we're gonna change it. But anyway, and let's just go let layout, and then we'll avoid that. So if you can go ahead and add that let layout, then we don't have that issue.
Let's see, you're typing on line 288.
Or yeah, anywhere before 290, right? Because that reference is basically a null reference, which you get to just see in the. So let me go here and see what I got. If it's loading up. Oh, wait. What's? Did I? Oh, so I did. I thought. Hold it. Wait.
And I'm also trying to figure out what you're looking at in the console, because I'm just getting a blank page.
Okay, hold it. Yeah, up here. Here's the, yeah. So I did that out of scope. So I'm just gonna grab this num instances as well for right now. I'm gonna actually put this, because I put it out. I realized I threw this in there just hodgepodge. I realized I put it out of scope. So let me just go ahead and put that down there as well. Or where was that actually? That was in, hold it, on, let me just, oh, so yeah. So I just need to actually set up, gosh, I thought I did this. As long as I keep the keys on here, it'll be the same. Anyway, so let me just go over here. I knew there was something I forgot to do before. So let's just go ahead and just put, yeah. All right, so that's fine. Just set num instances as a property on that object literal, and then we'll be good to go. So what? Let me see here. One more. Let me get. Oh, boy. Oh, because that's why. Because I'm backing up. Okay. Because I had layout object num instance. I should just have. I shouldn't even do. We'll just take out the whole GUI thing right there because I was using it as an object. Let me just take it out there, and I'll take the num instances. Actually, that was fine. Actually, before I just do what it had there at the beginning.
So now you're on line 95.
Line 95. Yeah. So again, I apologize for this. I was rushed, and then I went and was going back between work. So yeah, so that's basically hard coded right now into here. I was just declaring, I wanted to declare this num instances outside of this main function because it's getting set down in here. It's just getting hard set, but eventually I want you to kind of make this dynamic. And then use the dat GUI. And I started, because I was going to do this differently with the object on the GUI, but now I should just use, now I don't even need to use that object technique, right? I can just use, now, is it just directly like this? Now I'm forgetting my instances. I'm seeing if this is the right API for create on instances, create instances. Let me see if this is correct. So with the GUI, let me run that, see if I got it. No, that GUI is going to yell at me. Yeah, it's there. Well, I have you have that right there. That's gonna. I'll just look at the dat GUI. Well, we'll jump to this first here. So we'll come back to this line 290. I'm just for the simple variable num instances. Oh, it has property one. Oh, I can see that. 140 by 1. What? But let me, yeah, I'll just come back to that. I'll fix that while we're doing that. So over here, I console log the attribute location for over here, position location. And we can see that those are just integers, again, that are just pointing to some memory in the offsets in the buffer space for the on the GPU. And then we have these objects. These are from the uniforms right here, the projection location and then the view location. Because those are uniforms, there's really nothing but just like a prototype, object prototype in here right now. And the object prototype is allowing or facilitating the communication from the CPU to the GPU. And that's what these, that's why these last two things are just like these object prototypes. It's just like these empty objects that have some prototypal behaviors to them that we're not looking at right now. So going from there to the second question, which rotations are being changed in the render function and how? So if we go to the render function now, so So that's going to be so we can see there's the end of the render because it's just using request animation frame. So if we go up here, yeah. So line 224. On line 224, we're just taking this, in this case, setting the viewport to the full canvas size from the particular spot on the canvas, which is going to be the corner of the canvas, and making it cover the whole canvas. Down here is where we're doing the basically the projection, which is just an orthographic projection, which you can think of as taking a shoebox and taking a shoebox and cutting a cross section of the shoebox. So you're taking something like a shoebox, which is three-dimensional. In this case, the space that you can think of that's being affected initially is the clip space, which is three-dimensional, and you are essentially removing one dimension, because the orthographic projection, you lose a dimension in the process, right? So you basically, as we see in this example right over here, it looks like it's just completely flat. You don't see any like three-dimensionality other than the fact that, well, things seem to be behind each other, but you don't get the kind of projection distortion that you get with a perspective view. So with the perspective view, which is more common, orthographic view is common as well and has many applications, especially in mechanical systems that when you're designing them, or troubleshooting things. If you're a designer, a lot of times you want to put it in orthographic view so that you can see if things are aligned, because that way you eliminate that perspective distortion. So that's what the view, when we look at the orthographic view, we can see that's getting piped in over here. And that view at this line right here on line 243 is getting, it's getting mutated, it's getting changed, it's getting what? It's getting rotated along the z-axis, right? And the z-axis, is we basically lose that. That's kind of like the dimension that we lose in terms of kind of like visualizing things, other than like whether something's other than the fact of whether something is in front of something else, and even that can get messed up. But yeah, so this looks like it's flat. It's the whole thing is rotating. So this whole set of pluses is rotating, and then each individual plus is rotating. So the whole set of plus is rotating because the view is getting changed. The view matrix is getting rotated with this Z rotation call. And it's using I should mention it's using this library called M4. But I highly encourage you to actually go check that out and read through these implementations of these different matrix operations. Some of these basic, like linear algebraic, it doesn't have much of the complex like linear algebra stuff. It's just the basic kind of like arithmetic of matrices. But this is another Greg Tavares thing. Again, full attribution here to Greg Tavares. And but it's really nice to see, and it might make you want to break out and make your own implementation. You probably made your own math libraries at some point in time, I imagine, your own basic math libraries. But maybe you have made a matrix math library. But I think that could be a fun breakaway for a rainy day, a sunny day project for some people who don't want to go out in the sun. But yeah, the implementations of these basic matrix mathematical operations. So again, Greg Tavares. And let me close close that up. So actually, let me go back to the other document there. I'm sorry. And now I'll close it. All right. So the answer to that question over here, before we're going further, is which rotations are being changed within the render. We got the first one, and that's the view, and it's getting changed with that Z rotation. So basically on that line, that's not the same one. So up to the 220. Yeah. So on 243, it's doing that rotation of that view. And then if we go down into this down here, right, into the for loop right here, not as sophisticated and as exquisite as many of the for loops that we saw earlier. This is like super abbreviated for loop, because it only grabs the matrix and the index for that matrix, and basically according to the index, it kind of translates things a little bit differently according to the index. So you can see that this is getting done on the CPU side, which is interesting, right? So we're also kind of doing things like index specific on the GPU. So in this case, and this is what Greg Tavares did an example originally. So he's just taking each matrix according to its index, applying an offset right here with the translation call to the matrix, and then with a rotation call, doing a similar thing. He's adding a factor of the index as well to it. So the offset, if we go over to what I'm talking about here, how much offset, how much sliding translation there is basically, and then what the rotation, what amounts to a rotation rate, because this is happening every render, and obviously things that with the have. So which color has the highest index, and how can you tell? I didn't put this in there. This is a special bonus question. Special bonus question. Which color has the highest index, and how can you tell? Based upon this line of code right here, line 251, right? So this is line 251. Based upon line 51.
The light blue one, because it's going the fastest.
Yep, absolutely. That blue one, that teal one, or whatever, because it's rotating around the quickest. So we have two different rotations. Hopefully that's made it clear to you at this point, because we're kind of just like digesting that, making this digestible in like little nibbles, right? So at this point, you should be able to answer the rotations that are changing is the view matrix is being rotated around the z-axis. Of course, we're performing that rotation with matrix mathematics. So if you, this is a good time for you to go in and look at how a rotation, right? How do you do rotations of matrices? We're not going to take a break out from that, but how do you do that? And how would you do it if you were going to write it out on paper? How would you do that with a scientific calculator? How would you do it with MATLAB? How would you do it like in an implementation in JavaScript like Greg Tavares did? So those are the kind of things that I want you to celebrate, because those are going to empower you all along the way. Let's go to the next one. Go into the Chrome DevTools and run debug render. So in the console over here, you run it. Let me make it bigger so you can see it better. I'm sorry. So if I go over here, let me just drag this over a little bit. So in your DevTools, in your JavaScript console, you can just type in debug and then pass in the name of the function that we want to debug. So that, if you're wondering why I exposed render as on the window global object, it's for this reason. There's a lot of things that are just done for the, just for the purpose, including that whole big mishap of all those errors at the beginning. That was all intended. Okay, but anyway, I'm gonna go ahead and run that. Run the debug.
I just got undefined when I did it.
Oh, okay. So let's go back and look what you called. So it would be debug, and then inside of the parentheses render, R-E-N-D-E-R. Yeah, you get undefined back. Yeah, because the debug function returns void or undefined. It doesn't. Yeah. So but did you see what it did when I ran that, right? So it actually stepped into, right? It basically, right? It creates like a break. Let me just actually run this. Refresh this. Do that again. So if I go back to that, whenever I run this, it walks into that function, right? And it creates a break on the first line inside that function, creates a breakpoint automatically, and it's just part of the API. You can do all kind of other things in the dev tools. Now you can walk it, right? Just like you're gonna walk through some type of code, and you can resume it, or you can go through and bless you. But bless you. What I really wanted to point out here more than anything at this point is if you were not familiar with that, it can be very helpful. I'm going to show you a couple other tools in the future, including WebGL Debug, which I didn't put the link in the page yet, but yeah. So let me just bring that up. So WebGL-Debug.js, right? This is a great library. Don't ship anything into production or anything like this with this WebGL debug. Oh my God, it'd be terrible. But this WebGL debug, I'll put it in the chat for right now. I overlooked this. I'm sorry about that. I should have put it in the should have just put it in, yeah. So I put it in the chat for now. Essentially, this is a very good tool. There's a couple other tools out there as well. There's a couple plugins. I'll just put them in. I'll reach out later. If you join the
and I will later on put all of the chat links into the YouTube description.
Okay. But this is really great, especially when you start doing some really complicated shaders, and you can easily get lost in what the particulars are of their, because they throw you some really weird gibberish. They don't have these beautiful exceptions that they throw you. So this will give you some things to some nice sugary and well formulated like error objects to deal with. But I'll just leave it at that. Anyway, over here, if you're not familiar,
Eric, can I ask a quick question?
Yeah.
Can you use it to step through a shader, or it just gives you better?
Oh yeah. It just gives you better error reports. It doesn't allow you to step through a shader. A matter of fact, there are tools, there are GPU tools. Somebody was telling me there are GPU tools that are like, but they're specific to specific GPUs.
I see.
That people can do that, and there's like in-house tools. That's like something I was talking. It was Julie. So this one lady, she's a senior engineer over at Blizzard, and so they have like in-house tools that are like proprietary tools like that. Unfortunately, aren't open source. But what I do know about them is they're like GPU specific, and they can kind of do that. It's not as, since so much of the GPU, the moment you jump in to a fragment shader, you have to understand that all of those vertices can be happening at once, because the GPU is all about parallelization. Everybody say parallelization. Okay.
All at the same time?
Because I can't say it.
Parallelization. Oh, dang it.
But right, so you can't think in the normal kind of, right, yeah, if you're not already kind of into that mindset, because it's stepping through is not like stepping through this code right here, because all those Vertex shaders are going to be running like a lot, not necessarily, but they could be, for the most part, they're running it like simultaneously.
Yeah, I assumed it was impossible to do that, but then when you started talking about a WebGL debugger, I'm wondering, is it like simulating it or something?
Right. So that there's certain limited things that they can get, which is pretty much as like, I think from my understanding, what I heard is they can do they'll just do the GPU dumps, and then they'll like part way through some process. But I'm not even sure because it didn't tell me much about their tech. They are so guarded over there at Blizzard. They have to submit a paper trail up through the chain of command just to speak outside of their office. Yeah, again, they've already signed their life away on the NDA. Then they have to do it every single time they're going to speak it. So they just kind of double down on that. But anyway, if we go over here, you can look at, which is really cool. You can see within the local scope of the function. Within the local scope, we can see what the current values are. So as you're kind of walking the function, as you're kind of stepping through, I just kind of pointed this out because I think that as you do your own thing, you're going to find this stuff useful. And then there's another plugin which I'll share. I forgot to on top of my head. I have a couple other things that I use up here too. Might not like. I have WebGL Insight, which is good too. There's a couple other ones. I don't want to just go off on tangent, but WebGL Insight's another good one. I have that up there as a Chrome plugin. But yeah, you get the breakdown of your objects in the whole global. You can even look on the global in the window and inspect the global object right there in the local scope of the function. You can even get the closure that the renders within the main function, so you get that level. You get the whole scoping outside of the function that you did. So if it was in the closure of whatever, in this case it was in the main function, you can also look at the state there, and you can see the state will be changing as you're walking through this. And this is helpful for the next question as you look at these things in specific. So finally led to the next question, or I think it's the next question. But and that's like over here, or one of the questions that deals with the matrices and the matrix buffer, matrix data. No, it's matrices and matrix data, I think, if I look at the questions. Yeah, that's down here. It's a couple questions ahead, but it's leading right to it. What is stored in the variable matrices? So if you go over here, right, you can tell in the code. You can just look in the code, but you can also look over here in the dev tools. My intention was for you to kind of, if you weren't already acquainted with this, look at it within this closure scope of the dev tools. So matrices, we can see it's a, right? It's an array of float 32 arrays. Right, we have this right here, and you can go through each of them. Oh, we can see, oh, why are there, so there's 1, 2, 3, 4, 5, one for each what? So if we go over,
One
what?
for each plus sign.
Each plus sign, exactly right. So right. So if we think about those are basically the model matrices. So a lot of times in the generic literature, in the literature that's out there, right? You'll hear a lot of the times just the model matrix. So when you talk about the model matrix or the model matrices in this case, that's what we're talking about here. And those are the models, those simple models. They're the plus signs in this case. Let me drag this out. All right, I think I'm done with that right now. And yeah, close out. So let's go down to the next question. And then you can see what is stored in the variable matrix data. And then you can go there and answer that yourself. I showed you where that was. Or you can also look in the, right, you can also go down here and just see it, right, as well. So you can also, in glitch, you can just go over here, right, and go matrix data or whatever. And then you can see online, whatever, 165, you can see what it is. And then you can answer that yourself, which you should be. Taking the time, just thinking about this stuff, just sitting with this stuff. And then the next question is, what does VAO stand for? That's kind of obscure. Where am I coming from there? So I'm just going to type in VAO over here. We can see, all right, there's, says VAO. If I hit it again, it's defined up here. And if you see where it's, right, where it's instantiated as an instance of a what? A GL vertex array. So this GL vertex array is becoming our generator of what we're going to say is our vertex array object abstraction. So I bring this up because so when you go back to that presentation and you wonder why, like some of the things, and if you read up the general literature, or if you do some course, and if you get into other graphics related things, this is a current thing. Like 10 years ago, vertex array objects weren't even really the abstraction that wasn't, it really caught on more in the last 5 years, the vertex array object abstraction, which is cool. But anyway, this pertains over here. And so that's what VAO stands for. And basically, one thing I should mention, I didn't mention last time. So the VAO, we can think of that as a subsection of the memory that's in the GPU. In WebGL 1, everything was global in the GPU sense of memory. It was all just one big flat memory that's available to the GPU compute. But WebGL 2 changed all of that. And they came in and they basically, in having these vertex arrays that can generate this constructor array here can create these vertex array objects, if you will. Those end up becoming like a bindable subset. So if you think about what is it, the box, right? Does anybody tinker around with like the box layout of memory, like in Rust? They have like a box layout. It's kind of like that in the memory. It's like it's a block of memory. It's just a flat. You can just think of it as just a buffer or whatever. But it's a memory that you can bind, because when you get a real complicated program, you can have and you're managing the memory really wisely, and you're using the GPU for all it's worth, and using the CPU for all it's worth. It's like you're using your supercharger, your turbo, just at the right time. You kick them in right at the right time with your 350 small block, and yeah. So whenever you're doing the optimization, you're trying to get the most out of your system, and you're making it better. You will probably have potentially have a bunch of these vertex array objects that you're going to bind, and you're going to bind them, and then you'll bind something else, and then that will become the bound. At any one time, you're only going to have one bound. You're only going to have that one bound vertex array object is going to be bound on the GPU at any one time. So that's another important thing to understand. And the same thing. So, and here's another thing that's important as well. So the vertex array object, inside of that lives the attributes. And it was in the old project where I had that picture from the last week's, and I should have, that's what I was looking for that picture that I had from that video. But if you remember that picture, if you think about the memory on the GPU, the vertex array object is this block of memory. Then inside of that block, you have sub-blocks, and those sub-blocks are like your attributes. So the vertex array object is like the container that holds these attributes. That's why we have these locations that are over here, these attribute locations. Those are going to be like offsets within this buffer that is this vertex array object. And so at any one time, you can only have one active or bound vertex array object. And more specifically, you can have only one of those sub buffers, if you will. If you want to talk about it that way. you can have only one of those sub sections active at any or bound at any one time. So those are some. And then once you get the basic scheme of things, then you can really start to think where you can find room to optimize things. So that's what I was asking this question about, to get you thinking about what it serves, the VAO. What purpose does the VAO serve? Of course, you can research that. You can look up more information about that, put that in your own words as you post to the Supermedium Discord. Look at that. So that's what that was about. And then finally, as we go over here, I say use this tool. So if you click right there, it's like, really? Yeah. So use this tool. So it opens up over here. I already have this in here because it was in my local memory or whatever, it's in my cache. But you can go to this starter project. If you click on this starter project, it'll download this Sketchpad, little Sketchpad project. And then you go over into that tool, Sketchpad, and then you can open it up from there. Get where you open it up. Like terrible with Sketchpad. So is it drag and drop? No, export, open right here. Doy. Okay, so I click open right there, and then and then you just go over there, and you can open it there. And where's the import one? I just drag and can I drag and drop? I forget if I allow you to drag and drop it. I just drag and drop it. It said my drawing though. Setting. Oh, okay. It did show up when I dragged and dropped it. Did it show up for you? Like Micah, for example, or Jose or somebody, did it show up for you when you downloaded the Sketchpad project and then did that with the open? Or you're still trying to negotiate that?
I'm just watching you. I'm not following along at this point. I mean, I'm not trying to duplicate at this point.
All right. All right. So I get a little bit kind of little tiny steps when I do this because I'm used to teaching high school students, and obviously for them to follow anything technical, it has to be in real small steps, and they have to like technically write about it, otherwise they won't get it. But I think it's helpful for everybody. It's just like
I would just say it's downloaded a file to my computer, and it's different from what. So I tried to do what you did, and something different happened. So
you tried to import it. So let me see. Yeah, the import. Let me see.
Maybe I'll just go over the video again later, because it didn't work the same way.
So if I go open up here, oh yeah, it did, yes, and then I dragged and dropped it in there, and then it showed up.
I'm not getting anything. When I clicked on the links, what shows up is different from what you see. I'm not seeing the same thing.
Okay.
Yeah.
Let me see if let me just try something here. Show it in Finder. But well, let's do that again. And close that. Whoops.
It might be that just because I'm also managing the recording, I was just a little bit too distracted to follow along perfectly.
Yeah, let me see if I can. I just want to make sure, because this is, you can also make some really fun little primitives with this technique. That's why I find it. Let me just click rename on here. I'm just going to rename this to.
But the point was you're just showing us that you can design your instance in the Sketchpad.
Yeah, exactly. So I'm going to drag and drop it in there.
Okay.
Let me see.
Or people can import a 3D model as their instance if they wanted to. We could do a whole episode on that.
All right. So let's just go. over here. So basically, whatever you want to make, like the plus sign, for example, I just wanted to make some sense out of, and if you go back over here, right, so lines 134, and I'll make it bigger. If this is like too, I don't think it's too basic, because I think there's always little things that everybody can find as a, to step out with, and then you can think, oh, whoa, I can do something different with that. But so this whole array here of these vertices, right? Since they're doing the projection that's orthographic, they only really need, they can set everything at the same Z value, right? Because it's an orthographic projection, so the Z doesn't mean anything because they're projecting across they're projecting down the X, Y, and they lose the Z, any effect of the Z component. So that's why we only specifying 2 coordinates right here, because all the Z's could be the same. It wouldn't really matter, other than the order, I guess, relative order of things, if you're doing it that way. So all of these coordinates, like -0.1, 0.4, negative, you'll see there's some duplications here because we're not even using right? This could even be done more efficiently, because if you look at some of those are getting repeated, and that's for you to discover on your own and do. So over there, so if you imagine every single block on this grid was like 0.1, so that first coordinate over there would be negative 0.1, 0.4. So if we go negative 0.1, 1, 2, 3, 0.4, it's this top vertex right here. And what you'll be able to appreciate is the fact, the way that this is actually getting drawn. And it's not readily apparent just by the demo. Because what happens, it goes from this vertex. Watch the vertex that it goes to after this. And you'll see it in something else. So the vertex that goes to after this is negative 0.1, negative 0.4. So that it's going from this vertex up here down to this one. So it's actually cutting through this part of the plus. And then it's going to go, as you can imagine, to the 0.1, negative 0.4. It's going over, whoops. It's going over to here, to this corner. So it's going from down to here, to here, to here. So those are the 3 vertices. It's this triangle is the first triangle that gets drawn, because the GL draw call is drawing triangles, and it's actually drawing this triangle first. So there's actually some overlap in the triangles that are being composed to make this plus sign. And you see that, you see that if you were being like thorough and reading these positions, you would see that. But that's something that, right, even the most senior dev could just like overlook. And you can see all the little nuggets in there. You can see the repetitions. You can see where you can optimize further, right? And then if you go down into the code down here further, where we're getting down into the actual, oh, I should go up here further, I'm sorry. In the Vertex Shader, if you, for example, look for the influence of the, let's do the influence of the vertices. So let's let's uncomment the A position modified. If we uncomment the vertex influence, and then we comment this, and then we uncomment this. Again, we're overwriting the GL position here. We don't have, we're just saving ourselves some computation by doing that. So if we expose this right here, we already have the stuff up top uncommented. That's it. Now we should see the influence of, you know, the vertex influence on things. So if we go up over here and refresh it, oh my, now you can see how it's See how all of those, right? So per vertex, you can see how it's actually breaking apart each of those triangles. And you're wondering, how do you fit those triangles together to make that plus sign? It's because they overlap in the middle. See, it goes down over here and then overlaps. So that after you see them kind of exploded like that, like to say, then it kind of makes sense. So I just want you to maybe think a little bit more deeply about that, and then play with this more and more. Look at, and then as you look at Mignon's example, and then look at the incorporation of, you know, down the road, a Raycaster where you can start selecting certain vertices and based upon that performing logic on the CPU and propagating that effect back up through the uniforms like she did, then you'll have a much more well-rounded sense of this scope. So if I let's just say I commented out that one, and then I set, oh no, I'll just do that. No, I'll just leave that, and I'll just show you the influence of the index influence. See how that's a little bit different. So if I do the index influence, can you see how the kind of the rotations are getting kind of more wonky now?
Yeah.
So now you have that wonkiness, if you will, that's a technical term, associated with that influence of the index. So you can start to think, you know, how can you use these things to just on their own, just the vertex ID and the instance ID, and this is not even texture sampling for each of those. But I do want to mention one thing that if you recall how Mignon was saying when she was using the data texture, and she was sampling from that with using essentially the same basic two dimensions of information. She was basically, if we look at this, she was basically using the vertex as one dimension of information, and the instance, she was basically using those two data as two dimensions of information to give a coordinate in UV space that gets passed into the sampler, the sample 2D function in GL. So you can pass into that sample 2D, you know, a reference to the texture that's being sampled, and then the UV coordinate, that you have that returned data that you're looking for. And then she broke it down further, and she was using the alpha for her particular the state of whatever you clicked on, and so forth. Now, what's just happening, just like really recently, it still hasn't landed. It's about to land though in 3JS. It's already available in the overall spec and in WebGL proper, but implemented in 3JS, they're just about to land the 3D texture. And the 3D texture is you can take 3 dimensions to access a single point in the 3D texture, or rather than that, you can use the same two. You can use these same two data to access a 3D texture, but instead of getting like a row or getting you know, just basically basically getting a pixel, rather than getting a single pixel, which is like you're getting a vector 4 of floats. Rather than getting a single pixel, you can have a pixel, which is like a vector 4. You can get like a whole matrix, or even more than that, because it can be 3-dimensional. You can have a whole array of pixels for every vertex instance ID pair, and that gives you that whole extra dimension of all this other data that you can store there. So you can do a lot of fancy things at that point with that 3D texture and have all that and get really thoughtful in the logic that you pass, that you interact. Again, I stress that you should be interacting that computational logic with the whatever computation that has to be done should be done in the Vertex Shader if at all possible, unless it's just something that has to be done in the Fragment Shader. But those 3D textures are coming down the pipe. There's so many great optimizations that are in store once that lands for 3JS land. And I posted a link to that on the other Discord channel. Let me put that in there. That's something that's kind of, once I saw that was in the running, once that first the issue was first posted, I was like, man, I should have been on that, already. I should have seen that coming, and I'm glad that somebody did. Let me just jump into the so I just pasted that right over here, right? So in this document right here, texture, yeah, there's a couple of things right here. Let me open that one, and I'll open the actual pull, or the diff. This is the diff, is what it is. It's the diff for the, I don't know if he's ready, if it just has to pass the test and get peer reviewed or whatever. I think that's what it is at this point. What? Oh, hold it, wait, let me see. What's happening? Let me go. Oh, there it is. So if you just click on files changed, let's go back to that. Oh, that got rid of that. Let's see but add possibility to bind 3D textures and 2D textures. But you can look into the file diffs. I don't know. Oh yeah, there's the file diffs right there. See how that he was implementing that? And if you look at what's going on here, a lot of the stuff that you can see in the implementation at a certain point are things that we're dealing with, we're talking about. So if you look at down here, the object that he's using to abstract the idea of the three-dimensional texture, it's just an object, literal, with width, height, and depth. And you can go through and start to look at the implementation. He's starting to piece together and see what they took out. It looks like he was copied and pasted from the 2G one. I don't know why he would have that there. But anyway, this is good reading, and it goes right to what Mignon was saying about storing data state, keeping that active state in that texture. And that's so key in this world of optimization, because if you use these tools to the best abilities of them and the best patterns, you can get 1,000 times performance boost. 1,000 times, yes. So if you're like down at 3 frames per second, doing A-frame or something, if you're using the A-frame API and you're just doing something in a certain way, you're getting 3 frames per second, it's very possible that you could be pegged if you were using an Oculus Quest and you put that in the Oculus Quest and you fall over because it'd be so low frame rate. You would just you'd fall down. But if you did certain optimizations, it could be pegged at 72 frames per second. That's how impactful this kind of understanding is. And it's not that you have to code at this level every day. It's having this understanding, and it's kind of thinking down through the stack, right? And thinking across processors better, thinking across the CPU to the GPU processor. And then I linked over to this. I'm going to put this in the chat, or I'll put this in the document directly, I guess. Put this in the document. This is 3D texture. This is 3D versus 2D text. I'll put that right over in the document. And then here's the diffs for, I want to give him credit, because I think that's awesome. Very noble undertaking, David David, awesome, David from London. He's over at Sketchfab. I knew he'd be doing it. Sketchfab, what I'm going to be doing this weekend is something that they've already implemented at Sketchfab. It's in their proprietary code base, and I'll be trying to do the same type of thing this weekend with some. I can tell you this much: it's related to WASM, WebAssembly. But and then, so I got the 3D versus 2D. I didn't put the diffs in there, so I'm just going to put over here. I'm just going to say, what should I say? Exciting issue. It is exciting. Didn't everybody? Was it just me that got the goosebumps when you first saw those diffs? Was it just me? Was it just me? Come on, you did it.
I did go and look at it when I saw your link, and I was trying to figure out what they were doing. It looks to me like they're rendering into a texture, which I didn't quite understand that part of it, but I could see that they were doing this 3D texture stuff. So yeah, that's interesting.
Yeah. So in terms of the the abstraction above so these shaders are all well and good, and we've been pretty much at this point looking at over here, and it's a good idea. So down here in this code, we just have the shader, right? We have the vertex and the fragment shader, and then down below it, right, we get down into the regular. I'm gonna go up a little higher where it's at, blah, 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 I pass it up, boing, boing, boing. Right. Right, at the beginning. So at the very beginning, we're using this utility, and you should read this library too. This is another one of Greg Tavares' libraries, the WebGL Utils library. And you can see some of the setup that he does before taking in the WebGL context, and then the two shaders. So if you're just passing in the WebGL context and then an array of the two shaders, that's the API he decided for this function. If you go look in his little library, his little utility library, it's off to the side. I'm not going to dive off into it now, but you look at that, then you can appreciate the actual raw WebGL. But basically, you're just dealing with the program right there for your shader. That's well and good. This is basic. The program is associated with only a subset of the next abstraction on the CPU. The next abstraction is you don't deal with just the shaders. You deal with the shaders and a collection of attributes and uniforms. Usually just the uniform. Yeah. So or uniform. It depends on how you model your materials. So resources. You model the materials usually with uniforms, which will point to like resources, like texture maps, normal maps, blah 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 blah, and attributes, and different attributes. So if you go over there, going off of what, right? So over in here, you got the shader material, right? And the shader material, right? It has the uniforms and this is just a constructor for it, right? This isn't the actual material object that you get back, but it gives you some idea because you get a referenceable you can get the program through it, because when you pass it in these shaders, 3JS is going to go ahead and do that, right? It's going to compile the program for you, and it'll be part of that object. You can dig into it and get a handle on the program if you wanted to as well. And then you're passing in the uniforms. It takes care of all of that for you and just passes back a material object. So the material object, one more time, is the next abstraction on top of shaders that collects the shaders with uniforms, basically. And you could also say uniforms and attributes, but they're kind of overthinking it. They're just saying uniforms. But you could do their raw shader gives you a little bit. They don't have. They have injected uniforms. If you use their regular shader material, they will inject uniforms in it, like time uniforms. They'll inject certain uniforms into it. If you don't want any of I don't want any of your junk, man. I don't want any of your uniforms. I don't want to use it. Then you can just use the raw shader material and not have to deal with their uniforms. Sometimes you can get issues when you have unutilized uniforms, right? That can happen from time to time. So if you're ever wondering, if you're not using those uniforms over there, when I say over there, I mean on the GPU in your shaders. If you're not utilizing the uniforms, if you declare it, at least on the JavaScript side, you should at least declare it over here, right? On this side, because you can run into trouble if you don't at least declare it over there on that end. It's like starting a tunnel and not finishing the tunnel. You know the Boring Company, right?
Yeah.
Just think if they started that, how uneventful would it be if they just started it and then it just ended underground? It never did surface. It's just like, it's like that. It's like when you were creating a tunnel with these uniforms, you want to finish the tunnel on the GPU side, whether or not you end up using it within inside of the main function or any helper functions that you might reference or what have you. And that's something to note too. If you don't use it, if you're not used to the shaders, you can put as many helper functions as you want on the outside of this. Of course, you don't want to get overly verbose. You always want to be as succinct as possible and mindful of doing stuff in the Vertex shader. But that's pretty much it. That's what I wanted to kind of finish with, because it's the last thing I say down here is implement create instances and create instance along with the GL dynamic draw mode. What am I? So this is where I'm going to leave you hanging here at the end. At the very bottom down here, I put in a little skeleton for create instance and create instances. And then, so with these, now I should go fix that error, the .GUI. I'm going to have to fix this .GUI. Somebody look at it. Is it just to pass the name in and then the min max? I don't know what I did wrong with this. Is it passing not the only? I passed in the name of the. Because I'm used to doing it with the object, but I just wanted to use the number. I'm just gonna. Anyway, but what I like you to do is so similar to the fashion basically that Mignon was doing, right? So same type of thing. I want you to implement it yourself. I want you to use set up the .GUI with a number of instances, so you can just drag it and you can have however many you want. But this will walk you through, so you can create an instance. And I would just use this skeleton, use this form initially. Use this as your header, so to speak, or your abstract class or whatever. Passing in the offset X and offset Y, you create an instance, and then you're going to use that as a helper function inside of create instances. Create instances will get called whenever you change the .GUI. This is your homework. So all I have to do is see if I broke this right here. I'll just fix this. It's so embarrassing. Just fix this. Because I switched it at the last moment. I switched it. I said, oh, I don't need an object. I'm just going to make it just a single variable. Then I'm like, ooh. Then I realized I used the wrong API call for it. Now it's going to have an error. Oh, no, that is it. Oh, really? Yeah, it is it. You just have to pass it in as a string figure. Okay, but it just says, oh, yeah, that's why I used that as an object before, because it's just going to show up. Now I remember why I wanted to do as an object, because you can't even tell what the heck U is, right? You have, and right now it's just showing up as the U is the second letter. It's just going to take this text. It's taking the text as an array, and the first and the one is the letter U. Oh, this is so embarrassing. Oh my, I'm so embarrassed. See how you can do this? Just air it out. So if you have any reservations, if you're shy at all, just be comfortable in this space. I'm so comfortable all the time because you get ridiculed if you've ever like taught like younger kids, and you just make mistakes all the time, and you just get comfortable, live with the whole ridicule thing, because it becomes part of your existence. The only problem is when you strive for ridicule, that becomes the issue. Yeah. So other than that, let me just look at this. I'll get that right. I should do it as now I remember why I did it as an object originally, and then yeah, this is like the API documentation, right? Which is a little not how I would. Everybody says it's not how I document it, and then they would say pull requests are welcome. Okay. But over here, you can see GUI add, and I should have just did this. You should always wrap things in an object. It should be, because look over here. It's not, if you do something, it should be in an object. Because if you just do a basic variable, you're gonna end up with the same goofy thing. So let me do this right. Let me say, because now I understand why I was instances. Ugh! So let me just, so I'm quoting it. So this is great. This will be a live coding, and I'll just invert. So down here, first of all, where it's doing the instances in the, right here, I'm going to actually say, what am I going to call it? Layout or state. I called it layout. What did I call it? Yeah, because it refers to the layout, and I wanted to make some fancy. I'm going to call it layout, but it's going to be undeclared right now. I'm going to make a layout object dot instances. And I'm going to do the object up here. I'm going to say, and up at the top, this is what we all do. As long as it has the same shape, right, for an object, you can always make it a const. As long as you don't add or take away, you can't take any keys away or add any keys. But I'm just going to say install song equals, it's going to be 5. It's redundant anyway. But I just do that.
But you don't want equals, do you? Isn't it a key?
Oh, it's a key. Thank you so much, Mignon. Thank you so much for saving me. See, that's a pal. Thank you so much for that. Because I would have. Know what I would have done. Oh my God. But down here, we want to go ahead and now use the proper. So we want to use the layout. Pass in the object first, which in this case is layout, and then the key is instances 1 to 40, step by 1. Think it might actually work now. All right. And no. Oh, I'm on the wrong, refreshing the wrong page. What the heck? Oh, I got an error. Let me see what I did here. Where did I have? Oh, I got to get it in the other, it's also on those other lines. I got to get the other references to it. Is that 169 or was it? Let me get that. So this is good. Again, I'm just being totally transparent here. Layout instances, is it? Oh, down here again, I should have just aliased it up at the top, so I didn't have to do this. And let me just search for any further embarrassment. Oh. Okay, and I think we got it. A year later. There it is. See? It's like doing what right now? It's like doing the num instances. That's all well and good. But we don't want just that. That was the first part. You were actually supposed to hook this up yourself, but that's the first part. Obviously, that's not much of a ta-da. The next thing is inside of those, do the customization, right? And that's why those helper functions are there. So that's why these, or I should say the handler create instances. I need a handler on hand, but create instances right here is going to implement create instance, this helper function, that takes an offset X and an offset Y. This way you can also, based upon the number, and this is what I was wanting you to do, based upon the N, go ahead and do something fancy or integrate with something else. But yeah, make something of your own and head off towards, bliss, towards Mignon land right there, where somewhere out there, go out in that region, and then you'll find a happy place, and that's pretty much it. I'll take any if you have any questions. But I would go over that. I do the plug. I would add the plugins or the extensions, but there's a couple. There's WebGL Insight, but there's another one that I don't have on this computer that I forget the name of it. But anyway, I'm going to go ahead and.
I had a question about the sketchpad thing that you were showing. So did you draw something in there and then it figured out the overlapping triangles?
Oh no! No! I just hand drew this as a guide because what I was hoping you would do. Thanks for bringing that up because that's right to the point. No, I noticed the overlapping triangles must be the case whenever I kind of exploded it, right, based upon the vertex. I gave it those specialized offsets based on the vertex, and that's what kind of ruined the whole magic of it all. But basically, if you just use this or just hand draw it or whatever, you can do it in your head, right? But like being the teacher that I am, I can't see through the kids' heads and stuff like that. So I can walk around their desk, keeping my 6 feet at this point, but kind of looking back, trying to see. I don't see how that's gonna happen, but no, I can see. I just have them share their screen, or whatever, but and see what's going on. What are they designing? So if you go down over here to the line tool, right? I set it like at 2.5 pixels with a different color, and then whatever you want to make, and then just kind of do it in that space. If you want to make different things, it's kind of obvious. You can just like do it in your head, right? But I just get. Oh, I wouldn't. I was clicking and dragging. Why did I do that? And see. Okay. Stop it. All right. I didn't have that active. Let me make that unactive. And let me Command Z, and delete, and delete. Yeah, I can draw. That's what. Yeah. Yeah. And tomorrow we have a stand up with the design team. But so if you make something that is like, your own thing with the grid, I don't know what this is supposed to be. It's what it is.
Eric, are you meaning to share your screen? Because I don't think you are.
Oh, I clicked on share. Okay. Oh, sorry about that. I did click on share. Let me click one more time. Let me just share this last time. In the sketchpad, I just made something random. So you can see now, right? So yeah, so I just made something random. You make whatever you want to make, and then you can just put in the vertices.
Right. So you're making the triangles yourself. I thought maybe it had some export triangles function or something.
Oh no! Oh yeah. So in terms of into the GL calls, like most all the time, most rendering engines are gonna only make GL triangle calls, but you can make other calls if you want to. If you make them yourself with the same context, you can, if you want to. If you're like, man, I don't want to draw a triangle, I want to draw strips, or I want to draw whatever. There's advantages, obviously, to drawing triangles because there's only one normal for any particular plane determined by the triangle. That's why the triangle it would be kind of meaningless to be doing strips with normals unless you're doing something kind of trivial or orthographic.
Aren't strips? I thought strips were just strips of triangles, aren't they?
But this, oh yeah, right. They're arrays, strips, arrays of triangle strips. But the array itself doesn't have the individual triangles can have their. It just makes it makes it, you have to shift around the way that you're referencing like the normals. You have to do it differently, right? Because it's wrapped. The triangles are in there, but it's a strip. It's like an array, yeah, like an array of triangles. It's just not as clean cut for me. I don't know. Have you found use cases for that, Mignon?
No. I just remember reading that I think they used to have a few other types like quads and stuff that they actually got rid of. So I think all they have left are various types of triangles and then lines and points or something.
Yeah, in terms of that's a good question. In terms of going back to the thing, is that even, think so if I go over here.
And I have a request also, Eric.
Yeah.
Would you go and dive a little bit into the origin of the term binding? I've seen it a lot, but it's very abstract for me. I'm like, we're binding things to the GPU. What does that mean exactly?
Okay, right. So it's just basic binding. All it's doing is what it does is it marches the pointer on the GPU. It marches the pointer to the beginning of whatever you bound. So when you bind an attribute, first of all, you bind the buffer is bound, and then whenever you set attributes, like if I go into the code here, right? So whenever you're go further, right? So whenever, where did I do the VAO thing? So once you got this, you created this vertex array object and you bind it. At that point, it doesn't have anything in it, right? It's just like, it doesn't have anything in it at this point, but it's still bound. It has a memory address where it's going to start off, pretty much, in what it is. You can think of it as like a file descriptor kind of thing that it's going to read out of the memory, and then you're going to start to populate it with the attribute arrays. Whenever you enable this one right here, whenever you enable an attribute array, what you're doing at that point is you're doing a couple things. There's a little sugar here because you're actually even in the web. It's kind of funny to say that even in the raw WebGL API, there's a little bit of sugar, kind of, because it's kind of like binding that this buffer right here, the position this attribute buffer object. Because when you talk about this in general terms, you'd say like the array buffer or attribute buffer, or array buffer object actually is the proper term. But I interchange them, and other people do as well. But yeah, because they did. But whenever you bind this, binding is moving the pointer in memory, because you can only, it's that simple. Whenever the GPU is running, it is literally that simple. It has that one pointer. It literally has that one pointer that it's, and it even says over here, attribute pointer. When it's saying this vertex attribute pointer, this function right here, here it's kind of allocating, if you want to think about by enabling, and then it's actually setting that pointer, and it's more than that, it's defining the layout from there on. How big is it? How big are each of the individual things? In this case, like there's two coordinates, right? There's two coordinates, because it's just like, in this case, just doing like the X and Y or whatever, and they're just both floats, like two floats. And then down here, this is the stride. This is a little bit, this isn't too clear in terms of conveying the meaning, the 0. But if you put 0 in here, it uses these two previously declared properties, or and it uses those to figure out itself what the stride is going to be. The stride is how far ahead it has to jump for like the next vertex, so to speak. So the next vertex location, how far ahead does it have to jump? It's going to have to jump ahead based upon the size and the type. So if it was size 2, and in this case, these are two floats, right? So just based upon the floats, the size of float, right? They're float 32s, right? So you got the 8, times 4, right? So yeah, 8 times 4, you got the 32 times 2. That makes sense. You have the 4 bytes per float, and then you got the 4 bytes per float, and then you got the 2 floats per each set of coordinates, and then it has to jump that in the memory. The pointer has to, right? If you were thinking in assembly language, you have a go-to word. It's going to go to at that point. It's going to go to that next space in memory. So it's going to jump. It's going to stride through to the next to get to the next one. And then where is the position in the buffer? It's at 0. It's the offset in the buffer. So, and that's what the in terms of the attributes that are kind of declared, it's those, the offset will change with, or the offset will change like with other, where's the, where's the other, let's see, other attribute.
I have a suggestion.
Yeah.
Micah, about binding.
Sure.
Do you want to look at Eric? Since you're sharing, can you open up the WebGL2 fundamentals page?
The web page.
The WebGL2 fundamentals, Greg Tavari's page.
Yeah.
And then click on the WebGL2 state diagram. It's right at the top of your screen right now.
Yeah.
Okay, this is really awesome. So Micah, if you look at this,
Yeah.
So you can make that go, the instructions go away.
Yeah.
If you step through the code on the right there, you can see the binding happen. So you can see how there's that arrow there. It says the default VAO, and then as you step through the code on the right, you can use one of those keys. Does one line at a time. You can see the binding changing. This is so awesome. When I saw this page, I just could not believe how amazing it is.
Oh wow. Oh
so
wow.
You should definitely check this out.
Yeah, I will. I'll do this. I'll probably look at this tonight after the meeting.
And actually, I put a link to this in the notes in the last last meetup, but I
didn't even
catch
that.
Actually, to say anything about it, but I just think this is so awesome.
This is fantastic. Yeah, with the IDE stuff, so many of us are like used to using like VS Code or Vim or whatever, and don't even. I guess some people might use IDEs that are more full features that will give you the memory layout with your program, but this is very valuable. So I'm going to go ahead and stop sharing right now. I am signing off.
Awesome. Wow. Well, we've got everything. Yeah. We've got everything.
Well, thank you, Mignon. You are the inspiration. So,
Yeah, Mignon, you're technically ahead of the class. You've got you've gone
I
further.
get bonus points.
Sure. Wow. Yeah. This is great. I'm looking at the. You can't see my screen, but I'm looking at the WebGL 2 fundamentals, and I'll. Let me while I'm at it, let me go ahead and share. Go ahead and share my screen, and I'll go ahead and add the link. This is from last week, the one you added. Copy, and I'll add it to the so people can get it. Oops. Why is it? That's weird. Okay. I want to like paste it here, but it's like okay, paste, and then hopefully that will take us to the WebGL fundamentals. So that's on the page. We got all the links. Is there any more links that we want to share? All the links from the chat are now into the document. And let's go back. Not to this. Let's go back to this. And then all of these links are going to go into the YouTube. Does anyone else want to add any more links or any questions before we sign off? Or any thoughts?
Can't think of anything.
It's very exciting. This is like the very cutting edge of where WebVR is. Mesh instancing and modifying vertices individually. This is like frontier line code, and so it's very exciting that we got to talk about this today and broadcast it to YouTube. Really cool stuff. And the idea, some of the past meetups have audio issues. Like not all of them have sound, unfortunately, but there's still some good stuff. So I'm gonna share some of that stuff soon. But it's really so many, like the idea of, hey, well, one of the things, I think it was the 17th or 16th meetup, we were talking about, because Mignon wrote persistent, like a persistent world, and then we started to, and then Mignon created post-its where you click on a generator and it generates a new object. And then we started to bring in like different keyboards and different UI, and that so there's like this whole journey of us like trying to explore, well, how can we do post-its? And then somewhere around the 16th, I believe, is one of the ones that wasn't recorded. We're like, well, Eric is showing us this mesh instancing, which was in 3JS the first time I saw it, and then it was an A-frame, and Eric is changing the colors. He's showing us CS1, and each iteration of the CS1 is a different color, and then he says something like, yeah, and then we can modify the vertices individually. We could modify the positions of the vertices. And the idea that came up was, if we can modify the positions of the vertices, then you could technically, with JavaScript, transform. If you have a sufficient number of vertices, you could transform any instance into any object, as long as you have enough vertices to match the number of vertices in the object that you want to transform it into. And at that point, you can start to imagine that, well, wait a second, well, then you could create a whole bunch of instances, millions of instances, and they're all rendered in a single draw call, and you get really great frame rate. But then you could assemble this really, in the hypothesis, you could assemble this really detailed world where every instance is a unique object instead of being all the same objects, because each object, and the argument that I think Mignon was like, well, maybe that would be so computationally expensive, it would lose the advantage of doing instancing in the first place. And so
well, also, I mean, something else that I discovered when I was working on the demo that I showed is that there was a limit on how big the texture could be that I was using for my data. So I think that's going to be
And-
an earlier.
Yeah, so you're already you're not rendering a million instances right
Yeah.
now. So you've just based on what you've done, you've already run into performance limits, which is interesting.
Yeah, when I tried to do 20,000 instances, you know, where every instance just has 12 vertices, because it's just a tetrahedron, you know, that was already too much. Now I don't know where that limitation comes from. I mean, it could be that 3JS just decided, you know, they don't want textures that big, or it could be more fundamental. But I think you could do more than 20,000, but you'd have to start being more clever about how you encode your information.
Yeah. Another thought that I had was, you know, I guess we learned in a recent meetup that like when you add text, you're like every bit of text, every character is like another triangle or series of triangles that are being rendered to create that text. And so, what I was thinking and wondering, well, if we want to have a lot of if we wanted to have a lot of text, would it make sense to somehow you know, generate the text, but then create like a texture that represents that text, so that instead of rendering, you know, individual letters, would we save in terms of, you know, how much we're trying to render by converting that text into a texture? And does anyone know the answer to that one? Would because it seems like that seems like that's the opposite of the way it works in like a 2D web design, where text is less difficult to render than rendering a texture, right? But maybe in 3D, when you're rendering triangles, rendering text is more expensive than a texture. That's what I'm wondering. I don't know. Are you still rendering? Is you still technically rendering triangles in a 2D web page? I mean, that's what the GPU renders, right? So I don't know. Do you know?
I have an idea. What you could do is you can make 26 different instance meshes, one for each letter of the alphabet. So you have one for the letter A, right?
Yeah.
And then for every place that you have the letter A appears in a word anywhere, then you make one instance for that, and then the same thing for the letter B, and so on. How about that?
Yeah, maybe.
Maybe not.
I don't know. Yeah, I don't know. Well, we should try it. All right, well, it's that time again. I want to thank everybody for coming to this meetup, and I hope that everyone will come back for the next one every Wednesday night, Pacific Standard Time, 7 p.m. to 10 p.m. The Aframe Online WebXR Hacknight. Thank you. Thank you, Eric. Thank you, Mignon. Thank you, everyone else. Good night.
Good night.
Night.
Okay.
Night.
Oh, there's a couple more links.